Okay, so for this function, we want to once again find the discontinuities if there are any. And we'll once again take a look and notice that this function is made of two polynomial pieces. The first part, x squared minus 2, is a quadratic function. Second piece, 2x plus 1, linear function. We know that on their domains they are continuous, so there's no need to look any further into those pieces. Instead, we focus our attention on where the function is pieced together in its domain, which is x is equal to 3. So the first thing we want to do now is go through our definition of continuity, and we have to first take a look at whether or not g of 3 is defined. To find g of 3, we use the top piece of the function, so that's going to be 3 squared minus 2, which is 7. The next thing we need to do is find the limit as x approaches 3 of g of x. To find that value, we need to go in and take a look at the left limit and the right limit. And so our two limits, we'll calculate those in a minute. All right, so for the left limit, once again, we focus on the part that is left because less is left. So we once again have the value of 3 that is being squared minus 2 is 7. Now to find the right limit, we want to use the piece of the function where x's are greater than 3, and that's the second piece. So that's 2 times the 3 plus 1, and that also gives us 7. So because we have agreement of the left and the right limit, both equaling 7, that tells us that the limit as we approach 3 of g of x is 7. And the third part of continuity is making sure that those values of the function, g of 3, and the limit values match. And it's quick and easy to see that the limit as x approaches 3 of g of x is equal to 7, which also matches g of 3. So this function g of x is actually continuous for all values of x. And if you look at the graph that follows, you'll see that there's actually no breaks in this graph at all, no holes in it. It is a nice continuous graph drawn from left to right.